Welcome to aminacademy.com. In Laplace transform, let us do Laplace transform of some basic functions. Now, let the function is Laplace transform of sine hyperbolic function, that is sine h at. By definition, we can write integral of 0 to infinity e power minus st into that function, that is sine of h at dt. Now we'll start Laplace transform of sine of ht is Laplace transform of, we can express sine hyperbolic function as half of e power at minus e power minus at is for sine h. Which is, for the recall, half take out by using a linearity property of Laplace transform of take out, and Laplace transform of e power at minus Laplace transform of e power minus at by using linearity property. Equal half, we know that e power at is 1 over Laplace transform of e power at equal 1 over s minus a minus Laplace transform of e power minus at equal 1 over s plus a, where if s is greater than a as well as s is greater than minus a. Now this can be written as, take here s minus a into s minus b is s square minus a square. By cross multiplying, it becomes s plus a. S minus a into 1 minus 1 is minus s plus a, which is equal half this minus s plus s cut 2a over s square minus a square, and 2 also cut. Therefore, Laplace transform of sine h at we can express as a over a square minus a square. Now the same function can be done by using de Moivre's theorem. Now Laplace transform of sine of h at we can write as, it is the imaginary part of that one, minus I of Laplace transform of sine I at, since we can say sine of I theta we can write as I sine of h theta, which is equal minus I. We know that Laplace of sine I at equal Ia over a square plus Ia the square equal minus Ia over a square. Here I square is minus 1 and a square is minus a square. Now, therefore, Laplace of sine of hat equal I into I is minus 1 into minus is plus 1, that is a over a square minus a square. Now, let us do for another function is Laplace transform of cos hat equal, then by definition we can say this Laplace transform of integral 0 to infinity of e power minus st into dt is cos of hat. Here dt also there. But we know that Laplace of cos hat is equal same Laplace of, we can express cos hyperbolic function as half into in terms of e power at plus e power minus at. After that, by linearity property of Laplace transform, we can write this as half take out Laplace of e power at plus Laplace transform of e power minus at by linearity property. Now, which is further have, we know that Laplace transform of e power at equal 1 over s minus a plus Laplace transform of e power minus at equal 1 over s plus a if s is greater than modulus a. Now, which is equal half, here LCM of s minus a into s plus a is s square minus a square, that is multiplication of both factors. By cross multiplying, you can get 1 into s plus a is s plus a plus 1 into s minus a is s minus a. Then here a and a cut, we can say half into 2s over a square minus a square, then half the 2 and 2 cut. Therefore, Laplace transform of cos hat equal s over a square minus a square. We got the result. We have done. Please subscribe our YouTube channel.